All right, so for standard 17, I did problem 11.1.17. Find the Fourier series of the given function f of x, which is assumed to have the period 2 pi. This is the function. It was just shown as the graph. So that is f of x equals x plus pi from negative pi to 0 this side, and then negative x plus pi on the right side from 0 to pi. So then f of x plus 2 pi equals f of x because it's repeating. So let's start with a of 0, which I put down here. I don't know why. I did a of n first, but we'll go in order. So we have the equation 1 over 2 pi times the integral of negative pi to pi of f of x dx. So we can pull out the 1 over 2 pi, separate the integrals into two, negative pi to 0 and 0 to pi, plug in the f of x, evaluate that integral to get a of 0 equals pi over 2. And then for the a sub n term, it's the same thing, or same idea, I guess. The equation is 1 over pi times the integral of negative pi to pi, f of x cosine nx dx. And so same thing, separate the integral into two, and then evaluate the integral. For all of the even terms, it's going to be 0 because the cosine term would be 0 for those. So we only have the odd numbers. So a of 1 would be 4 over pi, a of 3 would be 4 over 9 pi, a of 5 would be 4 over 25 pi, and that would keep going. And then for the bn term, same idea. The equation is 1 over pi times the integral of negative pi to pi times f of x, but this time it's sine instead of cosine, and for this one it's actually going to be 0 because we don't have any sines for this, just cosines, so we don't need to worry about this term. So then plug all those in, and the series is going to be f of x equals pi over 2, which is the a of 0 term plus 4 pi times cosine of x plus 1 over 9 cosine of 3x plus 1 over 25 cosine of 5x, and that just keeps going on, and that's the a terms with n equals 1, 3, 5, etc.